Good afternoon, everyone. My name is Baron. Today, we would like to share our results for our buoyancy investigation. So this is our experimental question. We've been learning about buoyancy and relationship between mass, density, and volume in Mr. Alexander's class. So we know that density determines will an object will float or not, and buoyancy will show that how an object floats. In my home, there's a lot of heavy and light toys, so I was wondering that the mass of my toy affect its buoyancy. So our group prepared an experiment testing out whenever or not mass affects an object's buoyancy while it's in the boat. We think that this experiment could help our world, since that we can calculate out the maximum weight for a boat so we can prevent the boat to sink due to overweighting and cause people to die. So we predict that toys with a higher mass will sink the boat the most, and toys with a lighter mass will make the boat sink less. The reason that we made this hypothesis is because we think that if the toy is heavy, its mass will completely push the boat down, and since the boat is pushed, the deeper it will sink into the water. So these are our key words. Buoyancy is how a thing floats, and density is the mass being divided by volume, and mass is the amount of atoms in an object. So these are our equipments. We have an Iron Man toy, a pizza tower toy, a Ben 10 toy, a race car toy, a Mewtwo toy, a Metagross toy, a Snorlax toy, a Charmeleon toy, a Pikachu toy, a phone. The phone is used for pictures and recording, and a ruler for measuring, and a tub, and a boat. So these are our variables. Our independent variable is that different objects have different mass, and our dependent variable is that how much the centimeters did the boat sink. And the control variables are same. We use the same boat for the experiment and the same tub for the experiment, and we use the same amount of water in the tub and the same measuring tool and units. So first, we fill up the tub about in 80% of water, and we measure every toy's weight by using a scale and record it in the results table. And third, we put every toy in the boat one by one and make sure that it's the same boat while we're doing it. And four, put the boat along with the toy into the tub filled in water and make sure that not to spill water in the process, or else it might affect the results. And fifth, mark the deepest part of the boat that was sunk into the water and measure the distance between the deepest point and the water's surface. And repeat the steps for free. Repeat step 3 for the rest of the toys. And remember to take pictures and record videos. And at last, write down our results on the paper. So these are our results. We can see that the lightest toy, which is the Charmeleon toy, which only weighs 7.9 grams, only made the boat sink about 0.1 centimeters. And our heaviest toy, the pizza tower toy, which weighs about 104 grams, made the boat sink 1.6 cm. So we can know that our results supports our hypothesis, because since the bigger the mass is, the more that the boat sink. And another example could be that the race car toy weighs about 29.7 grams, and the Mewtwo toy, which only weighs 16 grams, has made the boat sink less, which the race car toy made the boat sink more by 0.1 centimeters. So these are graphs. You can see that the trend line is in a beautiful going up way, and yeah, which means that our experiment is successful. So that this graph suggests that as the mass of an object increases, the deeper the boat would sink. So our hypothesis is correct. So if we're gonna do this investigation again, we will use a smaller box to be our boat, because doing this, our experimental subject won't move to a side and make the whole boat sink and affect our results. And the next time we will choose the heavier toy so that the boat won't float around and it could be easier for us to measure. And at last, we will make sure that the water inside the tub doesn't leak out during the experiment, so our results won't be affected. And thank you very much. This is the end of my presentation.